Okay, this is going to be the installation instruction video for the electric starter for the EU2000i. And I'll show you on one that's completed over here real quickly. You'll have a radio power switch right here that allows you to turn the radio on. Turn the radio on, turn the fuel selector valve to the on position. Button number 1 will start the generator. Number 2 will stop the generator. Number 3 will put it into economy mode or take it back out of economy mode. And number 4 will turn this outlet off and on again. So to start the generator, it's real quick, push button number 1. Button number 3 puts it in economy mode. Button number 2 shuts it off. The electric start kits are not going to be anywhere near as simple as my radio or fuel kits for the other generators, because of the fact that this generator does not normally have an electric starter. So you'll have to make an electric start, then you'll have to install the fuel kit and the radio kit on it. So keep in mind that this one is going to be something that the tinkerer or model builder would probably enjoy. It's more about the journey than about the destination. First step is you pull this panel off, as you just saw. And we'll pull the front panel off and the side panels, the rest of the cabinet, so that we've exposed the generator so we can get down to business. The cover is just held on with the 4 bolts, and it kind of sticks in place because of this rubber gasket. The front cover will just ease it out a little bit because all the wiring harnesses for the inverter module are still holding it in place. This lower shroud, just pull out on the ends and it drops straight down. The same way with the shroud on this side. The 2 bottom bolts here and here have a 10mm head on them. And there are 2 more 6mm Phillips head screws here in the top. These two screws are different than all the other cabinet screws. These have a washer and no shoulder on them. This fuel tank support bracket has a single Phillips head screw holding it in at the bottom. The top you just unsnap. It's ultimately held in place by the half of the cover that retains it. And you'll notice this screw is the same as the other case screws in that it has a shoulder at the head of the screw. This particular generator happens to be one of the newest styles with the upgraded fuel cap for emissions. It's not going to make a difference as far as that aspect of the kit because the fuel tank as well as the fuel cap is completely removed to create enough room for the starter motor, the starter gear drive and release mechanism, the radio, the linear actuator for the kit, and all that stuff. To remove the fuel tank, all I did was I squeezed on the Corbin clamp and slid it down the fuel hose. If I can get this Corbin clamp into view here so you can see what I'm talking about. This is the fuel hose, and it was put onto this. You would just reach through this gap and squeeze here and here, and then the Corbin clamp can be slid up or down the fuel hose as you need. Save this Corbin clamp. You will be reusing it because when you reassemble it, you'll have a fuel filter going from here, or excuse me, a fuel filter connecting here, and then from there will be a hose going to the quick release mechanism at the top. I'm going to go ahead and remove the air box at this time also. It just creates a little bit more room for us to work. There is a breather hose that you'll have to slide off of the fitting on the air box. Then the air box slides out of place. Do not lose this gasket. As you'll notice now, the carburetor rocks loose. That's because the studs that held the air box on are also used to hold the carburetor on the side of the cylinder head. That's probably as good a place as any to take a break for a moment. Okay, the next step is going to be to remove the recoil start mechanism. Pop the little cover out of the handle. Use some kind of a clamp. Pull the recoil rope out just a little bit and clamp it so that when you untie the knot, it doesn't draw the recoil rope back into the recoil starter and add another step to the repair process. I'm going to remove the recoil mechanism itself, and that's done by taking 3 10mm bolts out. Or excuse me, 6mm bolts with 10mm heads on them. This last bolt is just a little bit tricky to get at, but nothing too serious. It's actually quite simple to remove that bolt, particularly when you compare it to how much trouble it'll be to put it back in again. Normally, when you pull on the recoil start, I'll show you from the side, you'll see that these two pawls move outward, which allows it to engage. See this? In the driven hub on the front of the flywheel. What we're going to do is put an inverted sprag mechanism inside here so that the electric motor will engage in the inverted sprag and the recoil start will still function as though nothing has been changed, so you can use recoil start as a backup in case of a battery failure or a radio failure or any portion of the electric start mechanism failing. So what we're going to do is we're going to remove the stock recoil mechanism so we can add our own to it. The only thing that will not be reused is the bolts themselves. We're going to be using bolts that are slightly longer and have a shoulder on them. If you look in here, you'll notice that the flywheel has a fan that is just loosely positioned over this hub. So make sure that you get the flywheel fan positioned back on. Then there is a spacer washer. You notice one side has sharp edges, and that side faces toward the generator. Then the recoil pulley, the bolts line up, and it goes onto the front of the flywheel, and it will be retained with some different bolts this time. Back to the original recoil start mechanism. We can start on that now. Ultimately, you have to be able to pass a 5/16 drive shaft through this. Right now the hole is slightly smaller than 1/4 of an inch, and it's not drilled all the way through. What I'm going to be doing is drilling it out with progressively larger drill bits. We'll just be going a 1/64 of an inch at a time, drilling it out larger and larger until we get to a 21/64. The reason I'm going a 1/64 of an inch at a time is because the drill bits will guide themselves, and if you went straight to a 21/64, it could walk off to the side slightly and you wouldn't even know it, let alone have the ability to do anything about it. But if this drill bit is a 1/64 of an inch larger than the one that I just drilled it with, then you have 1/128th of an inch outbound on either side. It will center itself nicely on its own. And at no point in the installation of this kit do you want to get overexcited and move too fast. There are plenty of opportunities to make mistakes. This particular step of the process, you can use a drill press or you can use a Bridgeport mill like I've got sitting over there. The only reason why I'm using it as with a hand drill is for the purpose of this video to show that it can be done with a hand drill. Out of the 5/16 and then finally to the 21/64. If you make a mistake, there's really no mistake you can possibly make that cannot be corrected. Excuse me, there's no mistake that I have found yet that cannot be corrected. That was our 24 or 21/64 cut. You'll notice now that the toothed washer that is pressed onto this stub, the stub walls are very thin. The only thing that this stub is doing is keeping this piece of metal from coming out, and this piece of metal can rotate slightly because when you pull the cord, it needs to be able to rotate slightly. There's not much tension on it. as far as the strength for movement on the X and Y axis, it will be reinforced by the fact that there's going to be a metal drive shaft running through it. As you can see, with the metal shaft running through it, it will be reinforced on its X and Y axis. It will have nothing to help it on the Z axis, but that's simply this toothed washer that's pressed on. You'll notice it is still a snug fit. The shaft is a 5/16 and the hole we just drilled was a 21/64. So it's still nice and snug. I'm just going to take a burring knife. It just cleans just a little bit of burr off the outside of this. And that'll be on both ends of the hole that there'll be a slight burr. Okay, that's probably as good a place as any to take a break for a moment. What I'm doing now is drilling a 1/2-inch hole in the back side of it, not all the way through. And what I'm doing is I've got a 1/2-inch drill bit, and I've just wrapped electrical tape several layers thick because I want this kit to be something that is possible to install without any milling machines or drill presses or anything else, just hand tools that somebody would have at the house. What I've done is I've drilled it out 1/2-inch diameter to the level of the weld. So what you'll do is you'll put your drill bit next to the shaft on the starter, and right where the weld ends, you'll wrap tape around it. And then you'll drill 1/2-inch diameter till the tape hits flush against the housing. And then you will go back and deburr it again. We'll take the motor, slide it in and test fit it again. When you get ready to bolt it down, you'll see that there are 3 holes that do not have the metal bushings in them, and 3 holes that do. The holes with the metal bushings are the ones that the bolts that attach it to the motor go through. So the starter cage will bolt to the front of the motor like this, with the pull rope coming out in the 9 o'clock position. So look at the very top. The 12 o'clock position will be a hole with a reinforced bushing. Then at about the 2 o'clock position will be another hole. Just above the center line, you'll see a slot. Make that slot centered with this mounting plate. There are 4 screws that come with the kit, and what they'll do is they'll go through from the back, thread in to the mounting plate, and then have lock nuts attached on top of that. The first screw is always the most difficult to get in, because that's when everything has to be lined up in the process. Okay, I've got the first screw started. Now I'm going to go and start the other four. This is a little bit tricky to do, but like I said earlier, it will give you a well-deserved sense of accomplishment when you're done, as long as it works perfectly. It's 3 started. Incidentally, what I do is I spin the inner pulley with the recoil rope starter and hold it where I want it with my thumb to get the best access. And keep in mind, the sides of these holes between the spokes will flex because, after all, the spokes are plastic. And just go around and make sure that all 4 of the bolts are in snug. Do not tighten them down extremely tight, because keep in mind this is a plastic housing and it will only tolerate so much. And the whole purpose of the 4 screws is, number 1, to hold the starter drive mechanism to the recoil housing, but also they will handle the torque load of the starter motor. So it won't be just the weight of the starter motor. The main load applied will be in the form of a shearing force trying to twist the starter motor off. When I look at it, I see a slightly bigger gap on this side than there is on this side, so I'm going to tighten these screws down over here now. So now the entire metal plate is down tight against the plastic housing. Before I go putting the lock nuts on, just pull the recoil and make sure that that moves smoothly. And then what I'm going to do is I'm going to power up the starter motor just to make sure that nothing snags in there. The easiest way for you to power up the starter motor is just to attach a battery to it. Okay. So my starter now spins smoothly. And now I'll take the 4 small nuts, put them on the back of these screws, and tighten them down. And that's probably as good a place as any to take a break for a moment. Okay, a couple things I'd like to point out. Number one, the motor is attached to the drive gear by a twist lock coupler. And I've discovered that the twist lock coupler can vibrate around and sometimes it can come undone out in the field. So what I've done is the twist lock coupler, and all it is this, which is bolted to the front of the starter motor. I've got one here that's not completely assembled. But this plate is screwed to the front of the starter motor, and then this goes in and it twist locks to the gear drive. The trouble is that can undo, so what I've done is put epoxy to keep this from unscrewing, and then on top of the epoxy there's a hose clamp that goes around this too. So that's the purpose of that. Do not remove the hose clamp. It does not interfere with the operation of the generator at all. And that should just about cover that subject. The next step is going to be to place it on the front of the generator, and we'll see how much of this shaft needs to be trimmed off, because keep in mind, Honda never intended anything to be bolted to this plastic housing. So no two plastic housings are going to be injection molded exactly the same. When plastic cools, it sometimes bows in or out. So I've left the shaft as it arrives to the end installer with a few millimeters of extra thread on it, so that no matter what you do, that shaft will be long enough. So we're going to test fit it on the front of the motor. These are the 3 bolts that originally held it on. You'll notice holding the flywheel in place, this is the end of the crankshaft right here, and this is the nut that holds the flywheel on. So we'll position the starter motor to where this shaft touches the end of the crankshaft. And now you'll notice that with the starter shaft for the starter motor touching the end of the crank, you've got a gap of about 5 to 6 millimeters between the metal reinforced gussets and the cast aluminum housing, which means that this shaft is about 6 millimeters longer than it needs to be. So what we're going to do is trim 6 millimeters off the end of it. What I've done is I've just threaded a 5/16 nut onto the end of this shaft, and that's so when you cut the end of the shaft off, you'll be able to take the nut off and it will clean the threads up as it comes off. the easiest way to do this, just go ahead and thread the nut out of the way. And on this one, I've got about 6 millimeters of extra shaft that I can cut off. And keep in mind, the drive hub is going to overlap by about 15 millimeters of thread. So I'm going to clamp that end in the vise, and I'm going to go ahead and cut it with just a regular hacksaw. And I'm going to cut it a little bit more than 6 millimeters off. I'm going to go for about 7 millimeters. Now if you look, you'll see that the thread has a tendency to collapse on one side, and that's why the nut screwed down over the end of the shaft is very beneficial. Now I'm just going to take an end wrench and unscrew the nut from the end of the shaft. Now we'll check it again. Okay, now we've got clearance. So what I'm going to do, the next thing is we want to make sure that when this is bolted in place, that this bolt comes through and lines dead on with the end of the crankshaft. We don't want it high or low, because if that's the case, the starter won't fully disengage. As always, with every step of this, just take your time. It's not a race. I noticed reviewing the last section of video that I took close to 8 minutes putting in the 4 screws that hold the starter drive to the plastic cover. So if some things take longer than you expected, it's not a big issue. So now what I'm going to do is just take a flashlight, shine it in here, and make certain. Here's what I'm looking for. We'll just say that this is the end of the starter shaft on a starter motor, which it is, and this is the end of the crankshaft. I just want to make sure that they are hitting evenly And if there's a gap of about 4 or 5 millimeters, that's still perfectly acceptable, because the drive spur that screws onto the end of this has about 15 millimeters of thread. So if you accidentally cut off more thread than you needed, that's not a problem. But you just want it to line up like this instead of like this, as close to dead center as possible. I'm going to say that these shafts, if you sight it from straight up and down, you'll be able to see if it's this way. And looking from straight up and down, it is correct. But when I sight it from the side, it appears that the motor shaft is just a little bit below the crankshaft. So the motor shaft needs to be pulled in a little bit. What I'm going to do is remove this cover housing and tighten down this bottom screw here and loosen up the top screw, so that will tilt the motor just slightly. So I'm going to go ahead and take this back off and do about a quarter of a turn tighter on the bottom screw and a quarter of a turn looser on this top screw to tilt it. And that's probably as good a place as any to take a break. Okay, what I'm going to do is loosen the jam nuts. As you remember, this bolt is the top, and the shaft for the starter was slightly lower, so we want to tilt it up a little bit. And to do that, I'm going to loosen this screw 1/4 of a turn and tighten this in 1/4 of a turn. So the first thing to do is loosen the jam nuts on both of them. Now we check it again. Yeah, I like that a lot better. All we're doing is just tensioning these screws. Like if it had needed to be side to side, then it would have been this one and this one. But since it's up or down, these two are almost in a horizontal plane. You leave these two alone, loosen this one, tighten this one, and that tilts the motor like this. Now, this is the gear that engages into the sprags, or the pawl mechanism. This is going to screw onto the end of the motor shaft. Then you just take an 11mm end wrench and snug it down. I'll leave that here for a moment. The mechanism that engages it to the flywheel is this. Incidentally, this portion here is just a tool. This is round, so when I chuck it up into my lathe, I can cut the round areas on it. And then these two surfaces are flat, so when I need to mill the reliefs or drill the bolt holes, I can clamp it up in my milling machine and hold it straight to cut that. So this portion is just a tool. The actual piece that you're going to be getting is going to look similar to this. That's an unfinished one. There are two pawls that are spring bound, and the spring moves them inward so that they will engage with the drive gear. So when you turn the drive gear, and it would be clockwise when viewed from this direction, it will turn the whole mechanism, which would include the flywheel, the crankshaft, and it would start up. Then once the generator is running, it will continue to spin the flywheel, but the drive gear will be stopped. Centrifugal force at 2000 RPMs will move the pawls out. And I can show you that here. Now with the pawls right now, you'll notice here's the center, and even when it's spinning you'll be able to see where the center is. And as I move it out with the screwdriver, and you'll be able to see this background, the pawls themselves will be moving so fast you won't be able to see them, but you'll be able to see where the screwdriver is. And when the screwdriver touches the pawls, you'll see it starting to shake in my hand, because it'll come around and it'll hit, and it'll come around and it'll hit again. So watch where the tip of the screwdriver is against the center. This is the center. There it's hitting. Here it's free. There it hits. So I'm actually going to here before it actually hits. So the paws, as you can see, because of the center of the screwdriver blade, are fully retracted at that RPM. In fact, you can see a very faint line right here where the screwdriver blade was touching the background metal. But you can see on the indentation here where it was at. So with the drive hub in place and the paws retracted all the way out to here, this now does not engage on anything. So what we'll do now is take this sprag mechanism, if I can only find my Allen wrench. This is the portion you'll get in the kit. That's simply the tool that I use to clamp the chunk of aluminum on to make it with. Okay, originally this is what the recoil start latched onto to turn the starter or to turn the motor over. And it was held on with two small 6mm bolts that went in here and here. These two bolts are going to be discarded because they're not long enough. If you look at these holes, you notice that they are an odd shape. That's not a mistake. The Honda EU2000 and the Yamaha EF2000, the flywheel configuration is slightly different. I am working on an electric start for the Yamaha EF2000. If you happen to have a Yamaha EF2000, do not hold your breath. This unit here, I had the original prototype running a 1.5 years ago, and I am finally ready to start shooting the kit instructions. But you'll notice that the Yamaha, I'm going to have it with these two bolts right here. So that's why there is the recessed bore for the Yamaha. The Honda, however, I'm using these bolts, and you'll notice that there's a double step. There's a shoulder right here, about 8 3/4 mm diameter. Then this shoulder is 6 1/4 mm diameter. And the way it works is that you'll notice that there's a relief so that this large flange, which is 16.5 mm diameter, will grip here. And of course the 8 3/4 mm diameter will lock into it on both sides. And then this whole thing will slide into the stock Honda recoil start, and then the stock Honda spacer will slide into this, and then the whole thing will bolt to the front of the flywheel with this nicely recessed. Easier said than done. First thing I'm going to do is on these bolts here, I'm going to use blue Loctite. There is a blue Loctite and a red Loctite. These bolts have red Loctite already applied to them. If in years to come, if you have to repair or replace these, I do strongly suggest, as you can see, that is red Loctite, which is considered a permanent. Let's take a break, and then we'll start installing this on the front of the engine. Okay, I'm going to put blue Loctite on the threads to these bolts. And I will attempt to get all this in there together. I use a deep well socket only because it is easier, it's not easy, it's less difficult. It's by no means easy. Take a flashlight and make sure that nothing looks out of place. Okay, if you look at the flanges on these two 6mm bolts, they're just about even with the lip on the original Honda starter drive, and everything is pushed down in there nicely. To tighten it up, what I do is I put a screwdriver. When I tighten it, it's going to try and rotate this direction. So I put the screwdriver through to where it holds the engine in a specific place, and then try to tighten up the bolts one at a time. And you just snug each one down in stages. Here the trick is to make sure that the wrench does not slide off the end of the bolt and you end up with skinned knuckles. Okay. So no skinned knuckles on it this time. Okay. So now what I'm going to do is I'm going to take the drive gear. I'm going to put it on to the end of the shaft, and I'll snug it down. This time, I'll start with a blank here. What we're going to do is same thing as before, but only what we want to do is make sure that this drive gear does not touch the back of the aluminum pawl holder. So we're going to slide it in. With this hitting, we're going to check and see what the depth between these metal inserts are versus the aluminum housing again. And And now it's going to be a little bit trickier than it was the last time because we have the pause of the starter mechanism to get this into. Okay. And now when you look at it, your gap is about 8 millimeters. With a gap of 8 millimeters, there's a couple of ways to do it. Clamp this end in the vise and cut it the same way that I did the original drive shaft, but cut it shy because you're going to do your last bit of touch-up on a bench grinder like 5 to 10 thousandths of an inch at a time. So if we say it's 8 millimeters right now, then you would attempt to take off about 7 millimeters at this time and then come back with a bench grinder. However, I'm going to cheat only because I can. I'm going to go ahead and use a lathe to cut this down. Go ahead and take a break while I answer the phone. Okay, what I've done is I've cut this nut down, not the full distance, but almost where it looked like it would be touching. We're going to go ahead and put this on and take another quick test fit because it's critical that you don't go too far. If you don't go too far, it becomes a whole lot easier. If you do go too far, you're going to have work to do. Okay, now we're getting down a whole lot closer to the final goal. We're looking at about 2 millimeters each for the gap on these bolts. This particular operation is part of what has held up the release of this in the kit form. I was trying to come up with a method that would allow the end installer to make this adjustment without a lot of machine tools. I'm just going to take this little burr off with a burring tool. At any rate, The method that the average installer is going to have to use is to hold this with a pair of vice grips, being careful not to tear up this surface. Or you can take and thread a bolt, 5/16 by 18 bolt. And that way you can thread this on and hold on to the bolt with the vice grips and just hold it against a bench grinder and slowly grind this backside off. What I'm going to do is thread it on backwards the first time just to knock any burrs out that happen to be nested. There, as you can see, where one's coming out right now, and this will push the burr out of the way just slightly. This particular portion of the job is going to require a lot of patience because it is so critical to get this one right. And if it takes a few hours, it takes a few hours. That's just what it is. Okay. Still got another millimeter or so to go. While it may seem inconvenient to keep checking, it's still important to keep checking. Again, I'm just putting it on backwards to use the main shaft to push the burrs out. And I'll turn the burrs off. And we'll take another test fit. It's probably as good a place as any to go ahead and take a break for a moment. Just knocking the burrs off. If it's any comfort to you, this is the portion of the job that will test your patience the most. I was simply threading it on backwards to knock any remaining burrs out of the way. When you put it on forward, it should go on easily. You should not need a wrench to start it with. The very last bit, I do recommend using a wrench to tighten it down, because you want it seated tightly against the shaft, because the torque of starting the motor is going to seat it down tightly against the shaft. And if you did not seat it down tightly when you were doing your cutting, your depth setting is not going to be correct. Nice. Now when I push it in place, I can just feel tension between these metal inserts and the cast housing when I slide it around. And keep in mind, it is difficult to get the drive gear into the pause to get this set into place. Get another drive here and show you something. What we were doing is when the drive gear sits, I don't want to mess with you too much, but you want the drive gear to sit down to where it just barely pulls away from the aluminum. It'll actually be recessed in there, and that's hard to see with the camera. But when it's together and you're moving the recoil start mechanism, you should actually have friction between these metal inserts and the housing. And this will just be a couple thousandths of an inch apart. And you may actually feel the pause. Let's see if I've got one assembled here. No, I don't. You may actually feel the pause engaging in this, and that'll make it hard to rotate in one direction. But now we have it fitted together, and I'm going to slowly turn the motor over from this direction, and that's for recoil. working. And now, if you have made it this far without gray hair, just make sure that your recoil retracts considerably. I'm going to move the generator just a little bit closer to this big heavy battery. And we can test the system. Now this is only going to test the start motor and the release mechanism. But if you're not a particularly patient person, it will either reassure you that this is all worth it if it works perfectly, or it will reveal that you still have more shimming to do. All this is a large battery that I'm going to power it up with, and you can use any battery you want to at this point. I imagine you will want to test it, because everybody wants a little reassurance that things are going good so far. Things that you want to pay attention to are going to be shine a flashlight into the gear mechanism itself and make sure that nothing is jumping. So we will go ahead and crank it and see what we get. And you'll notice that the motor is turning over. We just tore something. Go ahead and shut off. Okay. Once again, we're going to thread this on backwards just to make sure that there are no burrs hanging out into the path. And now it screws on fairly smooth. We're going to go ahead and turn it around now so it faces correct. For what it's worth, this is the portion of the job that is most likely to tax your patience if, when you're watching this, if you're thinking to yourself that you've got a shortcut. I don't encourage you to try shortcuts. Sometimes things are just difficult and you need to get over it. If you don't think that you would have the patience to do this, I don't recommend you're purchasing this kit. It's not my goal to sell lots of these kits. It's my goal to have the people that purchase the kits happy with them. Okay. Incidentally, the reason it's so difficult to get this slid in is because the paws advance and you're trying to work the paws into the start gear and yet keep this recoil housing from hitting the voltage regulator or any of the other flanges. So it is just a little bit difficult to get that slid in. Oh, so this time it goes smooth. It'll never go smooth again. Okay. Right now, I can actually feel friction between the metal inserts and the cast housing. So that's perfect. We've got the right amount of metal taken off of this nut and it's torqued down tight. So at this time, I'm going to put just a little bit of light oil on the pivots for the paw in the hopes that I may not actually be taking this apart again. This might be the last time. Yeah, right. Just so you know, the sequence of shooting the grinding down of that drive gear mount took over an hour to shoot. We did not shoot every single attempt and test fit. I just showed you enough test fits to get the point across. And that's with a lathe. If you do not have a lathe, you're going to be doing that on a bench grinder. And it won't take just an hour. It may take 3 or 4 hours. So that's why I urge you, if you're not patient, this kit is really not something you're going to enjoy at all. I'm going to pull the engine over by the recoil start just to make sure nothing looks really horrible in there. And make sure that the paws are advancing under spring tension so that they will engage into the drive hub. Okay. It looks good from there. And now, the first fun part of the entire installation. I'm just going to move this cart with the battery in it a little closer to the generator. With a couple of jumper wires. And we're going to test to make sure that the starter does indeed turn the motor over. If you've done everything correctly, this particular item will give you a sense of accomplishment and possibly a sense of relief that you did this part correctly, and give you some encouragement to continue on. However, if something goes wrong, it'll let you know what needs more work. Possibly the shimming, possibly everything. Okay, what I'm going to do is I'm going to look in here, and I just want to make sure that I don't see anything going horribly wrong. You won't be able to see it in there, and I can't hold the flashlight and the wire at the same time, so I'm just going to be watching in there. I'm not sure that that's enough light. If you hold the light in there, okay. So you now have an electric starter that will turn the motor over provided you've done everything correctly. You find that piece that's made up already. When you watch it, when you're turning it over by hand, this part will stay steady and the flywheel will turn over. What you want to do is make sure that the paws are advancing back into the drive hub by spring tension. Now you'll see this exact one, there's not quite enough tension because the drive hub obviously moves around. Like I said, this one's not finished yet. It's simply one that I assembled as a prop. But when you shine the light in here, you want to be certain that the paws, if you look at it, when the paw is on the tip right here, yes, it'll be pushed back. But as it rotates forward and it goes right to the tooth, when it goes to the tooth, it should be fully engaged like this. You don't want it to be way out here, just barely catching. If it's just barely catching like that, that's a problem. That's what you want. If it is barely catching, see if you can put a light oil on the paw, or drop it on the floor like that. It always helps. But at any rate, that would be something that needs to be resolved. Let's go ahead and take a break for a moment. Okay. Now that you've either verified that the starter motor does indeed turn the generator over, let me get the phone call. Okay, we've got the starter motor attached. So the next step to be able to remote start one of these is a choke. So now we're going to have to put a choke actuator on it, and we removed the air box in the first session of this video where we removed the cabinets. But the carburetor will now slide out on the studs, and you don't need to take the carburetor all the way off the generator. In fact, leaving it kind of hanging on the studs is a nice way to hold on to it. You're going to have to remove the electric stepper motor, which activates the throttle. So go ahead and crack the screws loose just a little bit and then back them both out. Unfortunately, there is a small spring and then a black plastic arm that actuates the throttle. So I'm going to take both the screws out, set them aside, and then I'm going to try and lift the stepper motor without shooting the spring across the floor. If you're doing this, I strongly recommend doing it in an area with clean floors at the very least. Because then if it shoots across the room, you at least have a small chance of finding it someday. Okay. Here is the plastic arm, and the spring shot out on me. Fortunately, I keep my floors clean enough that if something is shooting out, it's easier to find. I'll show you right now how this goes back in. If you look at the top of the carburetor, this is the throttle shaft. The spring gets compressed and this tab slides into this groove, and that's the way you'll need to put it when you get ready to reassemble it. I'm going to set it to the side right now so it doesn't go flying across the room and give me more practice looking for them. The reason I had to take that out is you'll notice that the choke mechanism has a serious detent to it, so it clicks in the open position and clicks in the closed position, and that's caused by two grooves cut into the back side of the choke lever that a small casting on the carburetor here rides into. So it's got a low spot here that'll click in, then a high spot here, and then a low spot here. What we're going to do is take a razor knife, and I'll show you from out here because it'll be easier to understand. But say if we wanted to remove part of this plastic, you'll hold the razor blade against it and work the lever back and forth, and it effectively scrapes this down. So we're going to take and hold the razor knife against the back of this, and what we're doing is we're removing just the finest bit of that plastic. Again, don't get too aggressive. This requires a certain amount of patience. It's not as taxing as setting the starter depth, but it does require a certain amount of patience. Okay, it's getting a little bit lighter, but still not where we need it to be. Let me stand over here. You need the whole radius on the back cut down, so you'll have to cut it from this side and from the back side so that you get it cut evenly. Okay, this portion is nice and loose here, but over on this side there's quite a bit of tension still on it. Got a little bit of stray plastic curled up here at the edge. I think it's causing me some problems. Okay. So now there's not as much tension. Okay. Now we'll be able to slide the carburetor back up and put the throttle linkage back together again. So the spring goes on just like this. Then the spring gets compressed into this notch. So it looks just like this. You'll see that right here there is a slot, and then it becomes wider for a slight gap there. This is the drive mechanism. Let me get the phone call. Okay, hopefully we can do this next part without another phone call. I've got the throttle arm in place, and what I'm going to do is I'm going to have to, with one finger, roll the throttle so that it lines up perfectly with the drive mechanism coming out of the stepper motor. And keep in mind, this recessed area fits over this boss on the carburetor, and this recessed area fits over this boss on the carburetor. If you'll back up with the camera, because I need to get my head in there. Okay. Okay, now you can come around with the camera. You can see where I've got, is the light putting too much glare on that? Okay, good. You can see where the metal shaft from the stepper motor is going into that receiver area. I'm just going to rotate it around just a little bit. And now we're in place. Now, tighten down these screws. And now we'll open the choke and look through at the throttle, just to make sure. And it is moving correctly. So at the rest position, the generator tries to start in wide open throttle, and once it's started, the throttle stepper will immediately engage and close the throttle down. But it's kind of like with the old cars where you used to start them with your foot on the gas. Okay, so we'll go ahead and slide this in. Put the gasket in place. The next thing we're going to do is drill the holes for the return spring and mount the throttle actuator solenoid. But let's go ahead and take a break. Okay, I'm going to go ahead and mount the actuator for the choke first before I drill the holes for the return spring. It just works out a lot easier that way. This is going to be used to actuate the choke. It's just a push-pull solenoid. You'll have a strip of bar with slotted holes in it. Cut one end off. So that you've got two slots. What I'm going to do is just fold one end over and then take a repairman's reamer and remount the end of this hole so that a 6mm bolt can go through it. I'm going to go ahead and bend this with a vise. If you have a brake, a small bench top brake, you can go ahead and use that. But the whole purpose of this is to demonstrate how to do it without a lot of expensive equipment. So all I've done is bend the end over, and then I'm going to take the tip of this hole and ream it out with a repairman's reamer so that I can put a 6mm bolt through it. The actuator will be mounted like this in the generator. So what I'm going to do is this mount tab will be mounted through this hole. We'll flip it upside down. Just put a number 8 screw in this loosely. So now with just a little bit of pressure you can get it to pivot. What I'm going to be doing is taking the 2 bolts that mount the ignition coil in place out, and I'm going to take them out one at a time, only because that'll make my life a lot easier when you don't have to line everything up just to get it back together again. So now the bolt will go through the bracket like this, and then through this bracket. Keep in mind that this piece of metal is flexible, and that will allow you to do some adjustment and bending and tweaking and so forth to get this linear actuator just right. What you want to do is stand back and sight right from the edge of the corrugated area on this tab and make sure that the linear actuator is in a straight line from there. So now if you come over to this side, you see where the actuator sets, and that is where we want it mounted at when it's permanent. I'm going to slide it in the mount hole that the screw goes through, slide it as close to the carburetor as I can get, and then snug down the screw. It's kind of a tight area if you got a really short stubby screwdriver, It'll make life easier. It's perfectly possible to do it without that. You could simply take the bolt out and then turn it over without rotating this shaft, and then tighten it down with a full-size screwdriver and put the bolt back in. I'm just going to tighten down the 6mm bolt that mounts the ignition coil so that now the choke actuator is held loosely in place. Next thing we're going to do is make the bracket for the other mount tab on the actuator, so you'll have two mount tabs. But right now this is probably as good a place as any to take a break.